Okay, should we begin?
Yes, sir.
Okay, fine. Yesterday, I think we had discussed up to class-based exceptions. So we had discussed this part, and probably we were here. Exceptions and constructors. So even through constructors, we can throw exceptions. Now this point, second point, is very important to understand. Suppose you have created an object, it means its constructor is being called and it is throwing an exception. If an exception is thrown from a constructor, it means that particular object has not been created at all. So what it will do, the second point is very important. Exceptions thrown by constructor cause an already constructed component object to call their destructor. Let us discuss this thing here. Let us create a class temp some integer I. Let there be a default constructor I is equal to 0, and let there be a parameterized constructor some integer x. I is equal to x, and here I'm writing, okay, let me write it here also. Cout inside default constructor and here cout inside parameterized. Okay, fine. Similarly, let's have a destructor as well. Cout inside destructor, and we'll also print the value of I so that we may be able to know that destructor has been called for which particular object. So here we'll write a try block, and suppose in the second constructor here I am throwing some exception, let it be throw temp. So we'll create temp t1. For this, the default constructor will be called, I will be set equal to 0, it will write inside default constructor and nothing else will happen. After that, we will call temp t2 with some parameters, say 20. So for this, the parameterized constructor will be called here. I will be set equal to 20, it will write inside parameterized constructor, and then we are throwing an exception. So what will happen? By the time this object is created or is to be created, this object is already existing, right? So here, let me write the catch block, catch integer some x, cout caught integer exception. Let there be another for catching all type of exceptions, cout caught unhandled exception. So here, let's run the program. So what will happen? Let me show you the output, then we'll trace it one step at a time. So here it is writing inside default constructor because of T1. Inside parameterized constructor, it is going inside the parameterized constructor and setting the value equal to 20. And then Because we have thrown an exception here, inside the parameterized constructor, we are throwing an exception. It means T2 object has not been created. So what it will do? It will cause the destruction of T1 object as well. As you can see, it is writing here inside destructor and the value of I is 0, which we had initialized here, right? So it means T1 also doesn't exist now. Finally, after executing this part, as you can see, it will write caught integer exception. It will come out of it. It will reach here. So the second point is very important. And when an exception is thrown by constructors, they cause an already constructed component object to call their destructor. So here it is. Only those objects that have already been constructed will be destructed. Exceptions and destructors. Destructors are called for all automatic objects in the terminated block when an exception is thrown. Let us take up one more example of this now. Here, we are not throwing any exception in the constructor now, right? We have created two objects. We are not throwing any exception in any of the constructors, right? So after these two statements, there will be two objects, T1 and T2, and then I'm throwing an exception. Throw 10. What will happen? This object's been created, this object has been created, then we are causing an exception, we are raising an exception, it will be caught here, and these two objects which have been created should be destroyed. Means their destructor should be called. You can see it here. First one is for T1, second is for T2. This is for parameterized constructor. So inside destructor, it means T2 will be destroyed first. The object created last is destroyed first. Then inside destructor, this is for the default constructor. Then it will, before handling the exception, it is happening. As you can notice it here. Before handling the exception, the objects will be destroyed. So then the exception will be handled, caught integer exception, then it will go to the last statement. So any acquired resources can be placed in local objects to automatically release the resources when exception occurs. So we have studied it earlier also that the purpose of destructor is to release all the resources and free the memory. If a destructor is invoked by stack unwinding we had discussed last time, that when an exception is thrown, whatever is on the stack that is unbound, all the variables are freed, all the identifiers are freed, any memory allocated that is freed, resources are freed, and so on. And throws an exception, further terminate is called. Okay. Once again, exception handling in constructor. What to do with an error in a constructor? Suppose there is some error in the constructor itself. What we can do, what kind of options do we have? Since the constructor cannot return a value, how do we let the outside world know of an error? Otherwise, what we could have done, that we could have returned a value and the calling function could have evaluated the returned value and accordingly taken some decision. But since constructor cannot return a value, what are the options? Keep defective object and hope someone else tests it. It is just like Sanuki, right? Constructor won't do anything about this. Then set some variable outside constructor, set the value of some variable which is outside the constructor, and a thrown exception can tell outside world about the failed constructor. So one option was it won't do anything. Second option is it will throw an exception so that the outside world may be able to know that the constructor has failed and it can take some remedial steps. Cache handler must have a copy constructor for thrown object. We'll discuss it just now. When an exception is thrown from the constructor for an object that is created in a new expression, the dynamically allocated memory for that object is released. So if you have used new operator in the constructor and then there is an exception, then the memory allocated through new will be automatically released. So exceptions and destructors. Thrown exceptions in constructors, then destructor called for all completed base class object. This we have discussed just now. We have seen the example of it. If the destructor that is originally called due to stack unbinding ends up throwing an exception, then terminate is called. This is repetition just. If object has partially completed member objects, then exception thrown, destructor called for complete objects. It will be assumed that even if the object has been partially created or completed, still we'll assume that it's been completed, and then we will call the destructor accordingly. Here, now we have discussed this part. Now let's jump to the next one. It is exceptions and inheritance. I had told you that the sequence of constructors doesn't matter if there is no default constructor or if there is no inherited classes. If you're having a default constructor, then that should always be the last, not constructor, a cache block. If you have a default cache block, then that should be the last in the set of cache blocks. Similarly, in case of inheritance, we need to be careful. New exception classes can be defined to inherit from existing exception classes. A cache handler for a particular exception class can also cache expressions of classes derived from that class. So here lies the main thing. The sequence of cache blocks for derived and base class should be in a particular sequence, I mean. It enables catching related errors with a concise notation. If both base and derived classes are caught as exceptions, then cache block of derived class must appear before the base class. Now let us discuss this part. Let us create two classes. Similarly, let's create a derived class from it. We have a base class and a derived class here. So let me write there destructors as well. Catch base b dot what, and similarly catch derived d. So here, in this case, this what function is redefined in derived class. Now, suppose I am throwing, without checking anything, throw base. Let's see what will happen. So we have thrown a base. What it will do, it will create a temporary object of base and it will be thrown. Let's see what will happen here. So it's writing here, because we have thrown a base kind of object, it will be caught here inside base class and it is reaching here. So if I change it to derived, see what will happen. We have written here in derived class for what function it should write inside derived class. But what is happening here? It is because of the problem with the sequence here. Instead of writing inside derived class, when we are throwing an object of derived class, instead of writing inside derived class, it is writing inside base class, because derived is a type of base. So the sequence matters a lot here. Derived class exception handler should be written before the base class exception handler. Let's run it again. So the sequence matters. Now it is writing inside derived class. So when you are throwing base, then it will automatically go to base class exception handler. Now it's fine. So if we put base class first, then the derived class catch block will never be reached. This is what we have discussed just now. So next is unhandled exception. What will happen? Yesterday we had discussed something. I hope you remember that. We had discussed that there is a sequence of events fired. First is unexpected, then is terminate, then is abort. Unexpected will be fired when there is some unexpected event, something which you have not handled in the program. In response to this, unexpected will call terminate. Terminate means it will stop the execution of program. It will free all the resources and so on. And terminate further will call abort. Abort means remove the program from memory. Terminate means stop the program. Abort means remove the program from memory, free all the resources. So this is the sequence of events which are fired when an exception remains unhandled. So there are three functions. First is unexpected, then terminate, and then abort. This is the sequence. Exceptions that are not handled by a catch statement cause the program to call unexpected. An unexpected exception is defined as an exception that is not handled by a catch block. By default, unexpected calls terminate. The abort function is at the lowest position, as we have discussed just now. So finally, terminate will call the abort function. These are supplied by standard C++ library. These are available there. So this is the sequence we have discussed just now. Unexpected calls terminate, terminate calls abort. Okay. What happens in this case? Let me show you. I can have my own function, my unexpected. Cout inside my unexpected. Similarly, I can have my own terminate function also. Void my terminate. You can name it just anything. That doesn't matter. The only thing is you need to define that these are your functions for handling unexpected event and terminate event. So here you will set unexpected, set unexpected, my unexpected. Similarly, set terminate, my terminate. So I can define my own functions for these. So here what I can do, suppose we are throwing an exception, throw 10, let's say, it will be got here. Here I can call unexpected. See what will happen. Let's see what will happen. Let's remove it first. Let them check what happens here. We have removed the base and derived classes. These are not needed. Let's check it now. caught integer exception. It is not causing those functions. And suppose we are throwing a float kind of exception or double exception, what will happen? It will be caught by unhandled. It will be caught by catch-all exception. And in this case, an exception is raised. Okay. There is some problem with the system. What we can do, we can define our own unexpected and our own terminate functions. Then we can set those functions through this, and whenever something unexpected happens, then these functions are fired. These are not working in this compiler, but otherwise they do. I'll have to check it. If these worked in it, then I'll let you know. Okay, proceeding further. Rethrowing an exception. Perhaps yesterday we had discussed that sometimes it happens that a catch block is not able to handle whole of the exception. It can handle some part of it, and it leaves the remaining part for the calling function. Let us discuss this thing also. So we can throw an exception from a catch handler also, or exception handler also. Let me show you this. Suppose we have a function void, let it be fact, for finding factorial of a number. Yesterday there was a little problem. It's 1 for integer f. I is equal to 1, I less than equal to n, I plus plus. F is equal to f into I. Yesterday perhaps I had written n here, it should not be. Now what we'll do, I'll write here try. Let me put it the whole code inside the try block, and then there will be a corresponding exception that would be integer x or whatever it is. So here what I'll do, if n is greater than equal to 0, then it should execute the code, else it will throw an exception. Throw n. So if the number is negative, the exception will be thrown. Here we'll catch it, see out invalid value x, and then see, this is something very normal that we have been doing till now. So I'll write a try block, and here I'll call the function. Let me call it with a value 10. Since it's a valid value, it will find out the factorial. Let me write it here. Return, and here return f. Okay. Here we'll write cout. Right. Let's see what happens in this case. So it is finding the factorial and executing it. Let me do it again. So it is finding the factorial of 10 and terminating the program normally. But if we are entering -1, -10, or some negative value, so what it will do, it will say invalid value. It should not return anything. Now, inside this catch block, we are handling the exception, and at the same time we can throw it again. So this is called rethrowing of an exception. When we throw an exception from the catch handler itself, it is called rethrowing of an exception. And in that case, there should be a corresponding catch block outside this also. For example, we are handling an integer kind of exception. You simply write throw without any parameter here. It will be rethrown, and then there should be another similar kind of exception handler. Caught integer exception again. I'm writing here. So it will be caught here again. Caught integer exception again. Right now it is not printing the value because this statement will not be executed. You will call the fact function. It will reach here. Since value of n is not greater than 0, it will throw the value here. It will come here. It will write invalid value. It will rethrow the exception. Rethrown exception will be handled by this cache block. Okay. So this is how it works. Even though we can rethrow an exception with an expression also, but it doesn't make any sense. Next is restricting exceptions. Restricting exceptions means when you're writing a function, for example here, I can restrict that it can throw integer kind of exception only. Along with the function, I'll write it can throw integer type of exceptions only. Or you can specify it can throw integer, float, or some other kind of exception. Then it will not be able to throw any other kind of exception. It will cause abnormal termination of program. And suppose you want that a function should not throw any kind of exception, then you will write here no except, no exception, right? You simply write this, then it means you cannot throw any exception from this function. If you will try to throw, it will be abnormally terminated. Just a minute. It was working just now. Oh, it's still, there's some problem in the compiler, I suppose. Because when we write here no exception, then it will not be able to, this function will not be able to throw any kind of exception, like it's still working here. There are few things about exception handling which are not working properly in this VC++ compiler. Okay. These are the exception handling best practices. These are already available in the PPT. You can go through those. I won't discuss all these again. And there is a summary also. So that's all for today.